Imagine flying nonstop for months without landing. No bed, no tree branch, no safe place to rest. Just endless sky. It sounds impossible. Every animal needs sleep eventually. Yet some birds spend weeks or even months in the air, barely touching the ground. So how do they survive without collapsing from exhaustion? The answer begins with one of the strangest abilities in the animal kingdom. Birds can sleep with half of their brain at a time. This phenomenon is called unihemispheric slow-wave sleep. Instead of shutting down their entire brain like humans do, birds can let one hemisphere rest while the other stays awake and alert. One eye closes, the other stays open, and the bird continues flying. It's almost like the brain takes turns standing guard. Scientists first confirmed this behavior in birds like ducks and frigatebirds. But the discovery that truly amazed researchers came in 2016, when scientists tracked great frigatebirds during long ocean migrations. These birds can stay airborne for up to 2 months without landing. Using tiny brain monitoring devices attached to the birds' heads, researchers discovered something incredible. While soaring on ocean winds, frigatebirds took micro-sleeps lasting just seconds, sometimes only 10 seconds at a time. Tiny naps, taken while gliding through the sky. But how do they avoid crashing? The secret lies in how these birds fly. Many long-distance birds rely on soaring and gliding rather than constant flapping. Warm rising air currents, called thermals, lift them upward so they can coast through the sky with minimal effort. During these gliding periods, the bird's body remains stable enough for the brain to briefly rest. But there's another fascinating detail. Birds often keep one eye open during these half-brain naps, usually the eye facing potential danger. That eye sends signals to the awake half of the brain, allowing the bird to watch for predators or obstacles even while partially asleep. It's like having a built-in night watch. Some scientists even believe this ability evolved not just for migration, but for survival in groups. Birds sleeping on the edges of a flock often keep the outward-facing eye open to detect threats while the inner half of the brain rests. Nature's version of rotating security. And here's the most surprising part. Despite flying for weeks, these birds actually sleep far less than they would on land. Frigatebirds get less than an hour of sleep per day while airborne, yet they appear to recover once they return to land. Which suggests their brains have evolved a remarkable flexibility that scientists are still trying to understand. So the next time you see a bird gliding silently across the sky, remember this. It might not just be flying, it might be dreaming. One half of its brain at a time, carried across oceans by the wind. And it makes you wonder, if humans had evolved to travel across continents through the air, would we have learned to sleep the same way?